Good morning, everyone. My name's Andy and I'm the Partner Manager for Bytes. Thank you for attending our webinar today, in which we're going to discuss data science. As Microsoft's #1 cloud partner, Bytes work with a number of specially selected partners who provide focused and highly skilled expertise in areas around Microsoft. Elastacloud are a lead partner for Bytes and have been at the forefront of data analytics and cloud technologies for over 8 years, and they have 4 Microsoft Azure MVPs. Gary Hunter from Elastacloud will take you through the webinar and we'll host a Q&A session at the end. A bit of quick housekeeping. During the webinar you are muted, but you can submit questions at any time using the questions box on the right hand side of the screen. Like I said, there is a question and answer session at the end to answer your submitted questions. The recording of the webinar will be made available to you, and also if you can complete the critique form at the end when you can request a call back from one of our specialists at Bytes. Okay, I'll now pass you over to Gary.
Thanks very much, Andy, and good morning everybody on this lovely early spring morning. So what I'd like to do in this webinar is really give you a flavour of data analytics and data science, how we use data science within Elastacloud as a business, what we do for our customers. So I'm going to give you some case studies from all different walks of life. I'm going to give you the backdrop to Microsoft Azure. And what I mean by that is the tools that we use within Azure, which you may have heard, a name that you may have heard is the Cortana suite or Cortana Intelligence Suite. So I would just like to show you how we use those different tools and how we stitch those together to create data science and business intelligence platforms. So just quickly to start really, predictive analytics and data science, well, what's it all about? The definition really is the practice of extracting information from data sets to really determine patterns and predict future outcomes. And I think everybody probably on this call is well aware of the terminology big data, and that there's a huge recognition by business leaders that it is really is a driving force within all industry sectors. Okay, so it's really all about forecasting what might happen, not necessarily what will happen. And what we mean by that is that, typically we'll put a probability score on something happening. So, for example, you may see in a weather forecast, the forecaster saying there's an 80% probability of rain. So we typically always caveat with a probability figure on there. But it's data analytics, predictive analytics is all about discovering hidden relationships to really advance understanding. It's better to know about something than to not. Within business particularly, you can identify potential opportunities, maybe revenue or margin opportunities or cost-saving opportunities, and also risks within an organisation. And I think importantly, it really moves us from opinion-based decision-making to true data-driven decisions. But it's fair to say that human insight is really critical. And we in everything we do, us and our data scientists really aim to work very closely with the customer to understand the customer's domain, okay, to really understand what you're trying to achieve and to see what comes out, see what we can do with that data. But the fact of life is we're seeing such large amounts of data now that machine learning and artificial intelligence really has to prevail. Human beings actually just can't keep pace with the large volumes of data that we're seeing, and I think you'll get a good understanding of that as we go through the webinar. Okay, so typically what's involved? This diagram just gives you an overview of the typical work that we do. And really it's all about taking both structured data and unstructured data. So the structured data you'll probably be all familiar with, typically can be SQL data, can be CSV, anything really that's coming out of systems that may be on-prem or in cloud. unstructured data is really what's driven big data. So things like sentiment analysis, things like textual text documents is really getting hold of that unstructured data and often combining the two, mixing structured with unstructured. There's a huge amount of data sets now that are available publicly on the web, and they can be hugely beneficial to us when we're looking for patterns and understanding what's happening. So obviously it's all about extracting knowledge and then having processes and systems in place. And as we go through, I'm going to talk about the Azure tools that we have within Microsoft Azure that really now make those systems available to any size of company, as opposed to it being just the domain of the very wealthy organisations. This is now these sort of tools are available now to every type of organisation. So typically, then we need to mine that data. Okay, and we use machine learning, which I mentioned earlier, and predictive analytics. Now, all of this is only good if you've got, out of the end of it, if you've got real actionable insight, or you've got insight that you can go and do something with. And visualization tools are critical to that. So as you see as we go through the webinar, I'm going to give you some examples of different visualization tools that we build. I mean, you can learn to build these, or we can build them for you. And it's all about visualizing for the stakeholders. There can be, obviously many different groups of stakeholders within an organization, and what they can do with the modern visualization tools like Power BI or perhaps even in Tableau, you can easily see analytics. You can see analytics and data live, so real time or near time. And you can also, as an individual stakeholder, perhaps a marketing manager or an IT manager, can do what we call last mile analytics, i.e. they can use Power BI or Tableau to do their own analytics. Now that will certainly, that reduces the strain on the IT department to deliver reports. Okay, so within our business, looking at the individuals that work in our business, I wanted to give you a flavour for those type of individuals and what they do. So we have data scientists, data engineers, and data analysts. Now, actually, over the last year, these three roles are often combining as people learn. And they learn the different disciplines within each of these. It can often come together into one individual. But really, let's start with what is a data scientist? Well, data scientists typically have a computer science degree, or a maths degree, or a maths PhD. Our data scientists have computer science degrees and maths PhDs, and the basic element of their job is statistics. But what they've learned through their time is really working with software like R, Python and Spark, and really how to build algorithms, so machine learning algorithms that they can deploy, and they can manage and train those algorithms to look for patterns and predictions. So what they'll do typically is build algorithms and manage that data. So a data engineer will, and when we come on to the Azure set, you'll get a good understanding for this. But a data engineer will build out a data pipeline, okay, and then manage the platforms. So we use our data engineers really to set up and configure platforms within Azure, AWS and GCP, which is the Google Cloud Platform. So they have to have deep knowledge of the tools that they're using and how to build out that platform. Now the data analyst will very much, their initial starting point is really taking data and manipulating and managing that data. Okay, so they will typically, they'll generate reports with that data, and they'll often do what we call hypothesis testing, so come up with a hypothesis and test it. But as I say, more and more we're seeing these three roles combine, and also with the engineering platform that we've got in place now with Azure, what you find is these things are actually relatively, the actual pipeline is relatively easy to build. The real skill comes in with the data scientist. Okay, so let's I'm going to use this infographic just to sort of build out on that really. So okay, this really matches skills and technologies. Now, as you can see at the beginning, talk about ETL. Now, ETL is the practice of extracting data. T for transforming that data, typically onto some intermediate server, and then loading that data into a system. Now, in the big data world, in contrast, we often use ELT, so extract, load, and then transform the data. So ELT really is born about with the large storage facilities that we've now got. And ELT allows raw data to be loaded directly onto a server, onto what commonly these days a data lake, and then transformed at some point in the future. Now this model can be more cost effective, as in the cloud world, storage is cheap, whereas compute is really where the cost is. Now the benefit of a data store, a data lake, is that you load your data in, you can store it cheaply, and then you can spin up servers or clusters of servers as you need them, and then turn them off when you don't need them. So you're only paying for the compute as and when you need it. Okay, so within Elastacloud, typically a data architect will manage the configuration and delivery of ELT or ETL or ELT. Once the data is in the storage, and that storage within Azure is typically Azure SQL Data Warehouse, okay, or Azure Data Lake, which we're going to come on to in a short while. So once the data is there, then the data scientist can really start their work using software tools that I mentioned earlier, like Python and R, and we'll go into those in a bit more detail in a while. And then lastly, you heard me mention about the visualization aspect. So lastly, visual representations of the data can be delivered via Excel, Power BI, and other BI tools like Tableau, etc. And that really gives the users, the stakeholders, clear views of what's happening and the opportunity to play with their data. Okay, so if we look at a typical data science project process, I thought it'd be useful to give you a flavour. You may be considering starting a big data or data science project. And I think it's worth taking you through a step-by-step approach that we take. So this is really a typical process. Now, we'll either be given a specific challenge or a specific set of challenges, or often we'll be asked to take a number of different data sets and to really play around with that data, let the data scientists do their thing, apply their techniques to it to see what comes out of it. And it's interesting, many of our customers say to us, well, we know what we know, but we don't know what we don't know. So have a play with the data and see if you can show us something that we don't know. And it's very interesting to see the patterns that a data scientist brings out, with not giving them any guidance, but it's very, very interesting to see that the patterns they'll often get great insight just by spotting those patterns. So, but often if you're starting a project, really think about the business objectives, what you're trying to achieve, and really start thinking about the project plan, what that project plan is going to look like. We can help you obviously with tools and techniques and get you started. But think about the data, really understand your data sets. As many of you probably will know, is what we call data wrangling, i.e. manipulating that data, perhaps cleaning that data, can be a very time-consuming exercise. But often it's important that it's done. There's a lot of techniques out there these days that can really help clean that data, but the cleaner the data, the quicker the data scientists can get into action. Now, often for us, it's all about integrating multiple data sets, and that can be hundreds of data sets. Is trying to link those different data sets together and then drive and look for patterns within those merged data sets. And then we go into really the modelling process. So the data scientists would take over and they'll build algorithms or use algorithms that are readily available and apply those apply those to the data sets to build out a model to make predictions. Then it's all about evaluating it. Has the prediction, has the algorithm worked? What sort of probability have we attributed to it? You know, do a sanity check of that. Okay, and then really deployment, looking if you're in a POC stage, looking at how you can then turn that into a fully developed system and really get the benefit out of the system. Okay, so just to recap really, the typical day in a data scientist is really solving problems to deliver actionable insights. That's really what it's all about. Understanding the data and the business objectives. Okay, a data scientist is trained and we manage our data scientists to work closely with the customer to understand, you know, the needs of the business and what the key hot buttons are in the business. Transforming data, you know, to give it a coherent and useful form really does take a significant amount of time within our organization. And implementing and creating new algorithms to make predictions on that data. And then studying and using the models to understand specific data, really understand what we're seeing and how that relates to the organization. And then using feedback to improve the algorithms. Data scientists are trained to constantly have a feedback loop. And these days, that's what machine learning is all about, really, is building algorithms that can learn as they go. But data scientists are very much trained in this approach. Okay, so let's have a bit of a look at machine learning and what it's all about. Okay, so many of you are familiar, everybody's familiar really with search engines. So really, what is machine learning? Well, I think a great example of machine learning is how search engines work. And if you think back to how Google started, you know, obviously it's a huge organization now, and it started off the back of building one algorithm, which is called the PageRank algorithm. So Larry Page and Sergey Brin researched really the mathematics behind the World Wide Web. And they worked out that what they wanted to build was a single, maybe library covering everything that was out there on the World Wide Web. Between them, they developed the PageRank algorithm. What they did is they analysed popular pages and looked at how these were linked together and really what makes that page popular. So then Google was formed, and really the goal is for them was to deliver the best possible search outcomes for users of the World Wide Web. Now, of course, then they started charging for advertising placements. But algorithms and machine learning algorithms now are deployed everywhere in search engines. And I think a good example here is misspellings. So every time somebody misspells something and then goes on to click on a page, then that is an algorithm, that's a machine learning algorithm that is learning as it goes. So that algorithm will improve itself and retrain itself so that for the next user, it offers them a better search experience. Okay. And algorithms are constantly deployed. Now, obviously, as you can see, no human being can keep up to pace with the changes that are going on right now within search engines. And that's why machine learning really will come to the fore more and more as we move forward. Okay, so let's have a look at the tools that we use in our business, and we're going to obviously focus on the Microsoft Azure stack. And I want to really talk you through and give you an example of how, what does what, and how we stitch all of these together to turn it into a business intelligence system and deliver data analytics outcomes. So this diagram really is used to show the different services that are available in Azure for analytics. Microsoft has invested huge amounts of money into Azure and huge amounts of money into the data analytics engine. So it attracts significant investment from Microsoft, and we all have the ability to really leverage the investment that they've made. But okay, starting over here, you can the idea really here is that you can ingest data from pretty much any source you want to. So data can be ingested from perhaps a CRM system, invoicing system, any systems you've got in your organization, or real-time streaming. So for example, you may be taking thousands of web orders every day and you want to see in real time what is happening. Are those orders up or down? You can go to product level, but basically you can stream anything in. You may be taking traffic data or Internet of Things data coming off of sensors and sensors on artifacts that you've got out there, pulling in your IoT data. Okay, so you manage that data within the layer here, which is the information management layer. Now actually you can then push that anywhere you want. So as an example, you might want to push it straight through the system into a Power BI visualization. So perhaps looking at real time, coming straight through the system from Azure Event Hub, which we're going to come on to in a moment, straight into dashboards of visualizations. Or you may be bringing data in and pushing it straight into a data lake or into a SQL data warehouse. You can take that data wherever you want and get it to where you want it to be. Okay, so Azure Data Factory is a globally deployed data movement service that is within Azure. So that gets the data moving to where you want it to be. So you would use it to ingest data from perhaps multiple on-premise and cloud sources easily, and then use Data Factory to get your data to where it needs to go. Azure Data Catalog is as it sounds. It's a repository of metadata that is a catalog of all data sources in your organization. So it includes things like server name, the data name, column data, and that column data is indexed and searchable. So the idea is that you can find data. You can also hold information such as telling a user how to get access to the data. So for example, that could be giving an instruction saying you need to join this group or you need to email Gary, that sort of thing. So it's a catalog of metadata to enable you to find data fast. Azure Event Hub is a highly scalable subscribe service, and that is what ingests millions of events per second. And if you wish to stream those into multiple applications. So that's your hub for streaming data in. And as I say, you can ingest millions of events per second and stream into multiple applications. So it allows you to process and analyze very large amounts of data from connected devices and applications. Now, from a storage perspective, you've got Azure Data Lake. And Azure Data Lake is an enterprise-wide hyperscale repository for big data analytic workloads. Azure Data Lake enables you to capture data of any size. So it comes back to the extract, load and transform model that we were talking about earlier. And I think the reason it's called a data lake, if you sort of visualize a lake of water, and you can go fishing in that lake at any time for data, but think of it as sort of unprocessed water. So if you have a lake of water, that water may then trickle down through the rocks and be processed, be cleaned, or you can bottle that water, or you can use it for fishing, whatever you want to do with it. So it's quite simply a lake and a big storage of data. It's actually just gone live in Northern Europe data centers. I think that was about 2 weeks ago, so it's very hot off the block. It was available in America for the last year, but just gone live in Northern European data centers. Now, Azure SQL Data Warehouse is a massive scale data warehouse with the ability to interact with big data, both structured and unstructured. So it's elastic scale on demand, and critically it separates storage from compute. So bear in mind what I was saying earlier about compute is really where the cost is, storage is cheap. So you can pause and resume compute, so you don't have to, you only have to pay for the compute as and when you need it, and you're only paying for storage as you go, which is cheap. Okay, so then we get really into the machine learning and analytics area of Azure and the Cortana suite, and this is really where our data scientists do their work. So Azure Machine Learning is a drag and drop workspace in Azure, and that enables you to upload data, get familiar with it, and apply ready-built algorithms. So I'm going to give you some examples in a short while, but within Azure Machine Learning, there are a number of algorithms that are loaded in that data scientists can take advantage of and use to work on their data. You can also build algorithms, new algorithms, within Azure Machine Learning. So that's really where our data scientists start writing algorithms or deciding whether they want to use a ready-built algorithm that's in there. And they then apply these to the data sets. They apply the algorithms to data sets to make predictions. So the data scientists will write in languages such as Python and R, and these are key programming languages for data scientists, and they do that within Azure Machine Learning. Azure HD Insight is Hadoop is Azure's version of Hadoop called HD Insight, and it's basically Azure Hadoop. So Azure HD Insight allows us to run industry-leading open source big data technologies. So it's open source, items like Hadoop, Spark, HBase, Storm, and again R. So we can create clusters on demand or on schedules. We want to schedule the spinning up of those clusters. We can use Hadoop without the complex setups and maintenance costs that are associated with these technologies. We come across customers who have spent very large amounts of money building out a big data solution maybe 5 or 6 years ago, and now what we've got to hand now with Azure is you can leverage that massive investment. Microsoft has spent the money and is constantly spending the money to really ensure that you don't have to and that we don't have to. So within Azure HD Insight, our data scientists have in there development environments. So you may have heard of these, Jupyter Notebooks and Visual Studio. And these are development environments that they can develop their algorithms and machine learning within there. Okay, so Azure Stream Analytics. Now, Azure Stream Analytics is related to Azure Event Hub. Azure Stream Analytics is integrated with the Event Hub. So if you think of it, the Event Hub collects the data, and Stream Analytics gives you the ability to do real-time analysis of the data as it streams. So it compares multiple streams, or you may compare streams with historical values and models. So when I come on to some case studies, I'm going to give you examples of how we've deployed Azure Stream Analytics to live stream and do predictive analytics basically on the fly. So you can detect anomalies, you can transform incoming data, trigger alerts when perhaps when the system sees a particular condition. So for example, maybe I had to use it to stop a fraudulent credit card transaction in motion, or perhaps with sensor data coming in, perhaps you've got a pump or an engine or something that's overheating. That's the way that you would detect that and spot it in real time. So these are out-of-the-box analytics services that are within Azure subscription, and they're constantly being updated. I think Azure these days is running at, there's something like 500 or 600 updates a month. So what we all have is we have Microsoft investing the money and constantly investing the money to deliver tools so that really we don't have to. Okay, and then as you see, dashboard. We've touched a bit on dashboards and visualizations. I'm going to give you some examples there. So really, this is the output. Really, what it's all about is getting data into a format that can be used and turning it into actionable insight. And typically, it's with data and dashboards and visualizations. But more and more, personal digital assistant. With Cortana, you've got that digital assistant. We're also getting into the area of what we call perceptual intelligence, and you probably would have seen things like face recognition, mood recognition. Microsoft calls that its cognitive services. So we have those tools available to us now. Okay, and then really insight is all about looking at the business scenarios and seeing how we're going to use that data moving forward. Okay, so just a quick look at Azure Machine Learning. I'm just going to use this slide to, it's a quick snapshot of what's in there. So as you can see, these different areas, these are different groups of algorithms. These different aspects that a data scientist will use in their workload. So multi-class classification is a statistical technique that data scientists use. Two-class classification is another one. Regression tools, another one. Anomaly detection and clustering. So these are all built in as standard with Microsoft Azure Machine Learning. So our data scientists will go into machine learning and decide whether they want to use one of the ready-built algorithms or whether they want to build their own. So I'm going to show an example of one of these, which is regression algorithms. Okay, so a good example of typically where a data scientist would use this. Let's just say that perhaps you rent cars and you want to accurately predict that demand for your product. So this is where a data scientist would use a regression analysis tool. So we're going to take you through just step by step what they would do. Is first of all get hold of your historical data. So you want to grab your historical data, and then maybe think about external data sets. So you might be looking at other data sets like traffic data or weather data or sentiment analysis or anything like that. Pull all your data together. Obviously clean the data if required, combine it and prepare it for analysis. And then that data is we then feed that data into Azure Machine Learning and apply the regression analysis algorithm to really, we're actually teaching that algorithm what to expect. And this is what's called a training model. So we're training that algorithm, adapting it for our needs. Okay, then we would test that model. So we would have a test set of data, and we would look at how accurately did did that algorithm work? And then typically we would go back and refine it and refine it and refine it until we make it perfect. Key point is, did it work? Okay, now actually, but here's step two, but you might then think of a further hypothesis. Once you've got, can you make that more accurate? As I say, you may wish to use weather data. One of the things that we come across is weather seems to affect everybody and can affect business in so many different ways, but I think a key element is what aspect of weather could affect your business. So for example, is that rain? Is that fog? Is it wind? These different things affect it in different ways. So typically we'd use this regression analysis model and then build out on that with other data sets and try to refine it and really understand what the causal factors are of what we're seeing. And we're looking at historical data here and then really looking forwards. Okay, what have we learned from history, and how will that be applied in the future? So okay, so I'd like to give you an example. This is pretty much hot off the press, but it's an event that we were involved in a couple of weeks ago, and it's interesting in a number of ways. So this was a data challenge that was put together jointly between Microsoft and Bloomberg's, and it was hosted at University College London a couple of weeks ago, and we were present to really help and train data scientists and add our expertise to the day. So Bloomberg's were set a challenge for undergraduate, for master's students, data science master's students, really looking for innovative data science solutions. So looking at Bloomberg data and seeing how they can improve it. And the challenge focused on the use of Azure machine learning. So using the tools that are there within Azure, and also then looking at data sets, things like news articles, ranking and sentiment, trend analysis. Really what they were looking at here is looking at, okay, news and events and how do they affect stock prices and how can Bloomberg benefit from that. So teams were judged on their ability to identify relationships between the data sets, news and news reports. And the interesting, here's a picture of one of our data scientists, Laura, kicking everybody off and getting them going. But okay, now the really interesting thing here is that the winning team were master's students from the University of Southampton, and they came up with a forward predictor which is not currently offered by Bloomberg. So it's an initial tool, an additional tool that Bloomberg can add into the suite of products that it sells its customer. And this team from the University of Southampton used data giving stock prices of defence companies around the globe, then looked at data sets with GDP and defence spend, and started correlating all of those with news stories. And the reason I wanted to include this today is because actually we and the representative from Bloomberg were blown away because actually their model accurately predicted weekly closing stock prices of 15 companies to a 97% accuracy over 2016. So if you can take that forward, you've got a significant opportunity there. So I think we were all blown away by what they achieved. So I just wanted to get that one across to you really. So I'd like to move on to some examples of our work and try to get across the areas that we work on. And if you think about what I showed you with the Azure tool set, I'll try and relate these back and show you how we've used each of the tools in different ways. Okay, so and as people will be aware, often we're under non-disclosure, so sometimes we can't show the customer themselves. But in this example, this is a major London venue. Now they're actually one of the major museums, and they have lots of disparate data sets. Okay, actually many more than the 120. But what they want to do is get a single customer view. So to understand, their customers interact with them in lots of different ways. When they walk in the door, when they go into shops, when they buy products online, maybe they make donations, they have a membership scheme, through Twitter, through Facebook, etc., etc. So they really want to get a full understanding of their customers and the journey that their customer goes through. So key starting point for us was really pulling those data sets together, and this just gives you an example of some of those data sets. So includes things like online sales, data from an invoicing system, data from email campaigns. Those email campaigns showed when the customer was first sent an email, how they've interacted with each email moving forward. The till data, so as people are in the venue and buying products, we're taking data out of the tills. We have survey data, SurveyMonkey, more MailChimp email responses. They run regular competitions, special events, and exhibitions within the museum. They also have an online audio guide, which is an app that you can download once you're into the museum. And what we wanted to do there was really get a handle on the physical visitor flow. So how people are moving through the museum. And this can affect revenue very significantly. So, for example, donation boxes. Donation block boxes are movable boxes that can be positioned around the museum. And actually it's key to have those. By just moving that donation box to where people are at that moment in time can make a huge difference. So what we've built from this is we've built out a complete single customer view for the museum. So they now have one tool that is built within Azure that they can do predictive analytics on, and we're working with them right now to do predictions over 2017, and we're pulling data in from the Office of National Statistics to give us a flavour for visitor numbers that are predicted to come into the UK, and including that is data like currency rates can affect visitors into the country, terrorism, areas like this. But what we're doing here is with the visitor flow, that is using Azure Stream Analytics, which I talked about earlier. So now they can see in real time the flow through the museum. So they can sit and monitor that, okay, with that Wi-Fi data, and that enables them also to quickly identify significant numbers of customers that actually they can help as they move through the museum. They want to be able to communicate with those customers and say things like, hey, the cafe bar is not that busy at the moment. Here's a voucher for a coffee. Go and have a coffee, knowing that they'll probably buy a coffee and a piece of cake as well. So they want to be able to communicate with those customers real time as they're moving. And then of course when they go away, when they finish their day there, is to be able to communicate with those customers ongoing. And have one single source, one single view of the truth on that particular customer, really measure that customer. And then we can look at things like churn rate, so we understand when a customer is disengaged, and areas like that. We can build out predictive analytics to help in all walks of life, and we can work out the lifetime value of a customer. Okay, another example is okay, sorry, bear with me one moment. Here we go. Okay, so another example is Mediatonic games. So again, here we've used things like as Event Hub, Azure ML, streaming analytics. So Mediatonic games are a games company. So a lot of people will play their games online. And the key business driver here was to predict when game players are going to quit the game. And this allows Mediatonic to give an additional incentive for that player to keep gaming. So Again, using Azure, a data lake was built which holds petabytes of historical data, which then we ran predictions on that data. And Azure machine learning is used to build algorithms. We built our algorithms to predict when players can quit. And then Event Hub collects data real time whilst people are playing that game at that very moment in time, and millions per second. And then Stream Analytics gives us that Stream Analytics. Now, by running this, we've delivered 90% accuracy. So we've proven, in fact, throughout 2015 and 2016, and this is a production system. This is working probably right now. So we proved that we could give a 90% accuracy when that player is going to quit. And Mediatonic Games are using this now with machine learning to ensure that it's constantly updated and it keeps their players playing longer. And that adds a significant revenue stream for them. Okay, ASOS. Many people know the brand name ASOS. We've been involved with them for many years. We actually started their migration over to Microsoft Azure, I think 5-6 years ago. So online fashion retail with a turnover of 1.2 billion, no stores or outlets, enormous warehouses, and I say transition to Azure. Now, when we started this process, we started looking at data analytics, we ingested 40 billion data points, and we spun up 500 virtual machines, and that completed our first pass of analytics in only 20 minutes. So it gives you an idea of the scale. Now, if we'd spun up 1,000 virtual machines, we could have done that in 10 minutes. So it is linear, but so that was the first place of the predictive analytics. And then what that led into was building out a machine learning based recommender engine. So if you go onto ASOS site now, and if you start looking around and buying products, what you'll see is their recommender engine is all based on machine learning. It's currently, it'll currently be looking across their base as people buy different products together. That algorithm is learning as it goes. And what they've got from that is they've got an increased basket size of around about 13%. They've reduced churn, and they've also got a very good handle on lifetime value of that customer. So from the day they first buy to perhaps the day where they haven't bought, they've got a very good handle, and this is all about driving up lifetime value. So obviously selling more to that customer, but doing it by showing them products that they're likely to buy. Okay, now just a very simple visualization here. What we're doing with ASOS right now is we're streaming data, okay, using Azure, and really firing out alerts. So we've got this now down to a product level. So if they're, let's say, for example, on a TV advert is running on the TV, and a particular item of clothing perhaps is seen on the TV, or perhaps seen in the Daily Mail. And what ASOS want to know is if there's a spike, if something's happening with the product, they want to know about it. And this system allows them real time to see if a particular blouse or a skirt or a pair of trainers or whatever it is see what sales happening in real time. Now, they may not be interested. There's no major anomalies. You just have it streaming out in the background. But it can be as simple as an email alert comes out to management to say, hey, this product's suddenly seeing a spike. What's going on? Or it could be a spike in a certain location in the country. So very simple diagram, but hopefully it gives you a flavour of how we're trying to transition this into true actionable insight. Okay, so another retailer, more of a bricks and mortar retailer, very large organisation, 10 billion turnover, and the work we're doing with this company was really all around their RFID tags. Now, you're probably aware, radio frequency identification tags. Some retailers use this. and put them on there on items and on clothes. They're relatively cheap these days, and you can do a lot with. There's a lot of data that's coming out of those RFID tags. So this organisation started working with RFID in 2010. Now they invested heavily in cloud era analytics. But what's happened more recently is with the modern Microsoft data analytics stack that you've seen, it's a lot easier and cheaper. Microsoft are really making that investment so that companies don't have to. So the work that they've done with Cloudera, and it was a very, very significant investment. What they've really discovered over the last 18 months is actually the Microsoft data stack can do this at a fraction of the cost, and actually is far more flexible. So what they wanted to do was really is do further development to truly monitor RFID, and that's things like giving specific refunds for an item. So if a customer brings a pair of shoes back into store and it's got its tag on, they can scan that through the till and they can see specifically, was that product actually sold, or maybe it was stolen, or what happened to it. So they can tie it to the customer, and this also relates to a loyalty card as well. So it helps them get a much better picture of the customer. It also allows them to monitor location of items in store. So for example, several items may have been picked up, and then as an individual walks around the store, they decide to not buy something and they put it in a different location. The retailer can very quickly spot that item is in the wrong location, get it back into the right location, and that could save a sale. So you can have incremental increases to sales during the day that add up and can be very specific. And again, a bit like what we were talking with ASOS, we've built real-time streaming of sales by item. So in the same way, at any moment, this retailer can see what products they're selling, in what store, and can visualize that in effectively a live Power BI visualization, and look for trends and see what's happening store by store, or comparing store versus online at any given time. Okay, so and that lightning fast pace of sales data is now deploying machine learning web recommender engines. So you can learn from store sales and apply that to web sales and do it at lightning pace. As opposed to taking a week to perhaps reprogram a web recommendation engine, you can do it on the fly, adding more and more data and making it much better. Okay, so we'll quickly, this was a case study that is all about web data predictive analytics within education, so within schools. Okay, now this was developed for a group of I think it was about 500 schools, and what we did is we built a data lake and imported log data, 25,000 different logs per second. It's about 200 gigs of new uncompressed data per day. And what we were doing here was really looking at what kids were looking at during their day. Okay, and we looked at the searching, their browsing logs, looked at the top internet domains for individual users. And really, we were working out, how much time are they spending using the web for true educational purposes, and how much time they weren't. Okay, so really, what we were building as the problem itself, and what we built out off of this was ability to provide long-term store to keep all data pre-processed in the system, processing messages again in real time, and applying machine learning to determine whether a request is a study request or a non-study request. We needed to do an experiment once a week on a data set to keep improving the model performance. And it had to have the ability to extract keywords from text, from document bodies as well. Okay, and really the ability to provide an aggregated view of study requests versus non-study requests per day. Okay, for time-wise, I'm going to speed through this, but we used, in order to put this together, we used all of the Azure tools that you've seen. So Stream Analytics, Data Factory, and Azure Machine Learning. Okay, and pulling data in as we're measuring, we're recording what the students are looking at online. Okay, so the outcomes. Using machine learning to know what kids are interested in and what they're worried about. So that was the point. What we could see here is it allows the organisation to really start building educational campaigns to improve how students are understanding or interpreting information they're given. So, for example, they could be sitting in a chemistry class and accessing data online and looking at that data. And that data is analysed, we're mapping that against the class that they're in. But of course it could be lunchtime and they could be searching for drugs or something like that. So it's really understanding what the students are looking at and when they're looking at it. And being able to then build out predictions, understanding perhaps early stage possible eating disorders and early stage diabetes and areas like this. Okay, so I'm going to come on to Rolls-Royce. Now, Rolls-Royce is a major customer of ours. We've been working with them for many years. So I want to give you a flavour of what we do. Now, we manage all of their aero engine data out of our office in Derby. Okay, so Rolls-Royce has been managing data for many years. So typically an engine has 2,000 sensors on it. We're delivering gigabytes of data per hour. And what's crucial to Rolls-Royce is it's all about collaboration. So collaboration between their partners, and their partners can include the airline manufacturers, the aeroplane manufacturers, so people like Boeing or Airbus, and can include the airlines themselves, and also their entire supply chain. So as I say, Rolls-Royce have been managing this data for many years, but our job really was to migrate them over to Azure and allow that collaboration, which was taking a huge amount of time internally. Okay, so I'm going to use some Power BI slides to demonstrate the front end and what Rolls-Royce see with real-time, pretty much real-time or near-time data. So on this screen, hopefully you can see this okay, but this is a Power BI dashboard. Okay, so it's built out of Power BI. These are all different data sets that are being pulled into Power BI. Some of them real-time, some of them near-time. And this is a good example. As you can see here, the red dot here, now this is showing to an individual within Rolls-Royce that there's a potential problem with this aircraft. So it's gone on to what we call an early watch list. Okay, and this is just standing out so they can see that there's a potential issue. Okay, next screen, again, these are Power BI visualizations. So this screen then really hones in, gives you information such as the crew that are on that flight at that moment in time. So as you can imagine, this is the front end, this is the visualization. So behind all of this is all the data sets that are going into this, constantly being monitored. So it gives us a bit of information. All of this these sort of things can be built within Power BI. Okay, it gives us a pointer as to where the issue is. Okay, and this is interesting because this is the sort of data that we're managing for Rolls-Royce all the time. It's a program called Flight Awareness, and this here is measuring the variance of the last flight, so expected and actual. And this is all about, I think this one's all about fuel consumption. Okay, so you can build out a Power BI dashboard to contain lots and lots of data. Okay, then another example of Power BI. So now you're drilling right down into where the potential problem is. Gives you an engine overview, gives you all of the service notes about that engine, and other information specific to that engine. So it's coming into one nice visualization. And then again, another visualization. This gives you more detail about the pump. Okay, so there's an issue with this pump. It's saying to us it's got 2% health left in it. Now this data here, the pump data, is also, we do a lot of work on components within engines to that then gets passed back to suppliers. So constantly looking for improvements from that supply chain. So this data will be passed back to them. Now this is the last slide on this Power BI, but what happens down here, this is then linked to Microsoft Dynamics CRM system. So if they want to request maintenance on this aircraft, hit that button and that really triggers everything to have the engineers with the right parts in place at the right time. Okay, so to Rolls-Royce, this whole program was key aspect was it's delivered a revenue stream for fuel efficiency. So this information is sold back to the airlines. So the predictions over fuel efficiency is being sold back to the airlines as a managed service. Okay, now it also reduced costs for Rolls-Royce internally through the predictive maintenance. The key point is it's a modern technology platform using Azure, completely scalable, built for the modern day age, we're constantly, at any given time, we're working on probably 30 to 40 different projects at a time with Rolls-Royce. We don't have to worry about the technology. The technology is there in place for us to really deliver whatever we need to deliver, for them. And that data platform was stood up extremely quickly. I think it was simply about 2 weeks to set that up and to get it running. Now that's worth tens of millions of pounds worth of revenue to Rolls-Royce, and as I say, it's future-proof, and we're working right now on further artificial intelligence and machine learning algorithms to improve efficiency. Okay, so then another example, but more around again like Internet of Things area. So this is an energy company, and they manage 300 plus solar and wind farms, and producing 2,500 megawatts of power, sensors on all of the solar panels and the wind turbines, generating about 14 million data points per day and generating terabytes of data per week. So again, we migrated this organization to Azure and built for them a single view of the truth, again, pulling together multiple data sets. And the areas that this has been most effective for them is predictive maintenance. So they can analyze solar panels and solar farms and look at perhaps where one solar farm is outperforming another solar farm, or one solar panel is outperforming another solar panel, and analyze that. We can look at historical data for all of the assets that they own. Now, one of the key areas here is we have to give accurate generation forecasts. So this organization gets heavily penalized if there is a plus or minus 10% variance in the energy that they deliver. And quite simply, they can do that now. And we're also adding new data sets. If you think back to what I was saying about weather and car hire, this can affect their business, or weather can affect their business significantly. And it could be as simple as you don't want to do maintenance on a day when you've got lots of sunshine. You want to be able to predict cloudy days or foggy days, and to be able to do the maintenance then. Okay, so hopefully that's given you a feel for all the different, or many of the different case studies that we've got and how we've worked with customers, what really data scientists do with their day. So Elastacloud is very much a business intelligence platform specialist, and just want to get a few points across about us. We're a leading data partner with Microsoft. Microsoft come to us on many occasions and involve us in in opportunities to deliver data analytics platforms and to deliver data scientists. So we're absolutely passionate. Everything we do is about driving value into our customer. There's no point in doing all of this if it isn't going to be actionable insight and something that can really make a difference to a customer's business. So we've got 4 what we call MVPs, Microsoft Most Valued Professionals. So these are 4 individuals with that, which is one of the highest levels of accreditation. And our 2 founders have another accreditation, which is Regional Director. Now this doesn't make them a Microsoft employee. It really is a consultancy board to Microsoft. There are only 150 regional directors worldwide. There's only 5 in the UK, and Elastacloud has 2 of those. And that gives us great insight into commercial terms with Microsoft, into product roadmap. Andy and Richard, our owners, do a quarterly conference call with Scott Guthrie, who is effectively the CTO of Microsoft in Seattle, and often Satya Nadella will be on those calls. So we are major contributors to custom Power BI visuals hosted within Microsoft Gallery. So you've seen an example of the visuals that we create with Microsoft Power BI, and right now we are the only external partner to be working with Microsoft to write and deliver their data science degree program. So we are working with them to set up a training center to deliver that data science degree program. So hopefully that gets across the great strengths that we have within Elastacloud. That's just a quick flavour of our customers. We work because the technology that is there within Azure and also the skill sets that we have within the organisation, we work across multiple vertical markets. Our skills are very, very transportable, and that gives you an idea of the different markets that we have worked in. So I'd like to just finish off by thanking you very much for your time. I think we're going to have a quick question session, but it'll be quite quick, I think. But what I'd like to offer you is a free data discovery workshop. Now in this, it's free of charge, no obligation. We would get some time with you and learn and visualize your organization, your sector. You will learn more about latest data platform architecture, that I've covered some of that today, and discover a bit more about the key statistical tools that data scientists can use. And we deliver a proposal for you tailored to your organization, containing a full statement of work that really kickstarts your journey down the route of actionable insight and data science. So it'd be fantastic if you would take us up on that. And we work to look at your business outcomes and then put together a full project. So if you're considering really getting involved in data science and big data, please do take us up on that. So lastly, I'd just like to say thank you very much for listening. Hope you found it useful. And we're just going to do a quick check and see if there are any questions so far. Right, okay, yeah, we've just got a couple of quick questions come in. Let me have a look. Yeah, interesting. Can I build my own data management tool? Well, yeah, okay, look, yeah, of course you can. It's a bit like building a car. I mean, I know how an internal combustion engine works, but I don't really want to go and build a car. So you can do it. I think the point I would make is that, it's all about time, really. We do things right first time and at pace because we've got the experience to do it. So I would, to be honest, I would encourage you maybe to work with somebody like us to get a knowledge exchange as we perhaps build out that data platform for you, and learn as we go along. I think we're very good at educating customers as we go. Okay, I've just got the second question was, have we worked in the finance industry? Yes, we have. Actually, interestingly, Clearbank, you might have heard of, is a brand new clearing bank. It's the first clearing bank to get a banking license in 250 years. We've built out all of their Azure architecture. If any of you are in the financial services sector, you may see that in the press. We built all of their architecture to enable them to get to the point where they're at. I think they're official launches in June, and we're right now building machine learning based anti-money laundering system for compliance, and we're building that right now. And then just the last question is, yeah, working in a university. I work in research in a university. We do a lot of intensive high performance compute in the university. Does it, will Azure work? Well, it depends what you're doing, but I'll give just one quick example that we haven't talked about. We're working with a major research institute that are doing exactly probably what you're doing. They're working with fluid movement, so water movement around ships in ports and areas like that, and the workstations they're using, I think the cost to replace those are about 15 to 20,000 pounds each, and we've successfully run their models in Azure, and they're blown away by it. So yes is the answer, but we're very happy to talk to you about that offline if you would like. So just goes for me to say thank you very much again. If you'd like to submit a question about the webinar, please email it, as you see on the screen, and to tell me more at bytes.co.uk. And thank you very much for your time.